Alright, in this problem we're going to show that the secant of a divided by the sine of a minus the sine of a over the cosine of a is equal to the cotangent of a. I'll start it like I start everyone by writing proof. And I'm going to pick this left side. I think in the book it says to just change this into that. This is the more complicated side, and I want to simplify it down to this. Right away I see that sine over cosine is here, and you might be tempted to change this to tangent. I'm not going to do that because I have fractions and I want fractions. Right? If I want to try to put these things together, I want to be able to add these fractions together somehow. Right? If I had tangent here, actually I would probably change it to sine over cosine so that I would have these as fractions and try to get a common denominator somehow here. So I see these fractions that I want to add together, and immediately in my head I'm thinking combine them, get a common denominator. So I'm going to rewrite the secant of a over the sine of a minus sine of a over the cosine of a. This fraction on the right hand side is missing a sign, so I'm going to multiply this by sine over sine. I can do that because that is just a big 1. This side has a cosine, this side does not. I want to make it have a cosine, so I will multiply by cosine over cosine, because that is just equal to 1. It doesn't actually change anything, it just changes how it looks. So I'll actually do this multiplication, where this top becomes cosine a times secant a, all over cosine a times sine a. And this will become sine times sine is sine squared over cosine a times sine a. And again, I haven't really done any trigonometry yet. I've just multiplied by clever ones to get them to have a common denominator. I've actually done the multiplication. Here I'm going to combine them now because I have these fractions with a common denominator. And I'm going to take 2 steps at once. I know cosine times secant is 1. Right, and I'll justify that right away. That is a reciprocal property that lets me say that. And that 1 is over cosine times sine. And sine squared is also over cosine times sine, so I can merge them together here like this. Cosine times secant was 1 minus sine squared, all over the same denominator of cosine times sine. Lets me rewrite it there. And now I have 1 minus sine squared. I see squareds, I have difference of squares. That is a Pythagorean property. That is equal to cosine squared. I'll justify here. Now I have a cosine on top, cosine on the bottom. I'll cross one of those off, so cosine squared is 2 of them, 1 down there. So I'm just left with a single cosine in the numerator, and the cosine is gone from the denominator. So all over the sine. And cosine over sine is cotangent. Quotient property. And that's what I wanted to show. So I started up here that secant over sine minus sine over cosine was equal to the cotangent, and I just showed that. So I'll write, therefore, that's true, and that's what I wanted to show. This one's one of the ones that looks more complicated, that I have 1 over 1 minus cosine of x plus 1 over 1 plus cosine of x. I'm trying to change that to 2 times the cosecant squared of x. Started off by rewriting, and I've already got this here because I know I'm not really going to change anything. I don't want to use any properties to change cosines to 1 over secants. That's just going to make this be an even uglier fraction, like stacked on top of a number and a fraction. What I want to do is be able to combine these somehow, get a common denominator that's going to end up being that conjugate of each of these separate pieces down here. that I'm going to multiply by the big fancy one that I see 1 minus cosine of x. And even if this wasn't 1 plus cosine of x, I would still think to multiply by this thing's conjugate, 1 plus cosine of x, on the top and bottom, numerator and denominator, and I'm allowed to do that because it is just a big fancy one. And on this side, I have 1 plus cosine of x, and I'd want to multiply by 1 minus cosine of x on the top and on the bottom. I'm just going to get rid of that here. So now, A, they have a common denominator, and B, when I actually do this multiplication, I'm going to end up with that difference of squares, that a squared minus b squared, or a plus b times a minus b is equal to a squared minus b squared. So my top on the left side is going to become 1 plus cosine of x times 1, doesn't change it. On this side it'll be 1 minus cosine of x. And each of these is going to be under a common denominator. I could FOIL it all out. I'll have 1 times 1 is 1. 1 times negative cosine will be minus cosine. Cosine times 1 is positive cosine, and those are going to cancel. And cosine times negative cosine is negative cosine squared of x in each of these things. They have a common denominator, so now I can push them together. That this is just 1 plus cosine x plus 1 minus cosine of x all over 1 minus cosine squared of x. Again, haven't really done any trig stuff yet, so I haven't had the need to justify any of my steps over here except for algebraic pieces. But now on the numerator I have cosine minus cosine. Those are going to go away, and I'll just be left with a numerator of 2. And my denominator is 1 minus cosine squared. That's a Pythagorean property. That is just sine squared. There's my justification that I need. And 2 over sine squared is the same as 2 times 1 over sine squared, and the reciprocal of sine is cosecant. The reciprocal of sine is going to be cosecant. Reciprocal of sine squared is cosecant squared. But use the reciprocal property. And that's it. So I just copied already what I wanted to show. So I say, therefore, 1 over 1 minus cosine of x plus 1 over 1 plus cosine of x is equal to 2 cosecant squared of x. QED. That's what I wanted to show. Right, in this proof, we're going to show that secant of x times the quantity secant x minus cosine x is equivalent to tangent squared. So, start off, write proof, restate that left side, and immediately, instead of changing things to sines and cosines, I see this secant out front. There's a parentheses here. I'm just going to do this distribution. I'm going to say, let's do secant times secant and secant times cosine. So this becomes secant squared of x minus secant times cosine. I just distributed right there. But secant times cosine, those are reciprocals of each other. So I have secant squared of x minus secant times cosine, that's just 1. Reciprocal property. And secant squared of x minus 1 is tangent squared of x. Hey, that was a quick one. Right. Justify Pythagorean property, and therefore shorten that line there. Secant times quantity secant minus cosine is equivalent to tangent squared. Quod erat demonstrandum. That's what I wanted to show. This next one is very similar to the one we just did. I want to show that sine times the quantity cosecant minus sine is equal to cosine squared of x. It's going to be about the same length, pretty short one here. I'll do the same thing to start. Distribute sine times cosecant and sine times sine to rewrite as sine x times cosecant x minus sine times sine is sine squared. Another reciprocal property here, sine times cosecant is 1 minus sine squared of x, and I'll justify it. And 1 minus sine squared is cosine squared. And that's it. We have sine of x times cosecant x minus sine x is equal to cosine squared x q e d. Hey, this next one has a few different ways that I could do this, and I might do a couple of them here. I want to show that cosecant squared minus cosine squared times cosecant squared is equivalent to 1, which that's kind of weird. I have the square of some trig function, and I'm subtracting the product of two different trig functions, and somehow that's just going to make 1 every time. Let's show why that would work. First way to do it, I think, is maybe the simplest. I'm going to leave that first term as cosecant squared. And over here, I'm going to change this cosecant squared to be 1 over sine squared. That would be a reciprocal property there, so I'll justify that step. And you might be wondering why I chose to just change this 1 and not this one over here. Well, I'll show you in a minute. Because this side, right, this is really just cosine squared over sine squared now. Right? This whole thing, cos squared over sine squared, that's cotangent squared. So keeping this in mind, I have cosecant squared was still there. Cosine squared over sine squared, that's cotangent squared. And that's a quotient property that I'm using there. And cosecant squared minus cotangent squared, that's one of my Pythagorean properties. That's just 1. And I'm done. Right? I think that's the quickest way to do it, is I didn't change this one, I just wanted to match this one, and I knew it was a Pythagorean property from the start because I've been working with those a bunch. So, therefore, cosecant squared theta minus cos squared theta times cosecant squared theta is 1, and that's what I was trying to show. So, there I go. An alternate way that I could do this is to change both cosecant squareds into 1 over sine squareds. Or, algebraically, right, like, I could factor out this cosecant squared. Right? This is a cosecant squared times 1. And so, there's a cosecant squared term in both of these. So this would become cosecant squared times 1 minus cosine squared. And often we'd go back this way, I'd distribute it, and I could get this. But here I could just factor out the same cosecant squared term in each one. Okay. So we got not really a trig property, I'm just doing some algebra to bring this out. Now this, cosecant squared theta, 1 minus cosine squared, that's sine squared theta. Pythagorean property lets me say that, and now I have the product of reciprocals again. Cosecant squared is 1 over sine squared times sine squared, that's just going to make 1. So that's a different way that I could have done this exact same proof. Another one would be that, yeah, change cosecant squareds, change everything to sines and cosines. Immediately you'd have a common denominator of sine squared. This would have 1, that would have cosine squared, and you put them together and you'd get 1 minus cosine squared divided by sine squared, which would be sine squared over sine squared, and you could finish. So a few possibilities on what you could do for this one. They're all equally correct, and yeah, you just get to pick what you want to do. Alright, problem 33 in the textbook. I'm trying to prove secant theta plus 1 times secant theta minus 1 is tangent squared theta. Record time here. I start with the left side, and I I'm going to distribute this across, FOIL it, and secant times secant is secant squared minus secant plus secant. Those terms are going to cancel. 1 times negative 1 is minus 1. So I get secant squared theta minus 1, which is just the tangent squared of theta by the Pythagorean property. And that's what I wanted to show. That's all that one is. Whoa. Times secant theta minus 1 is tangent squared of theta, and that is what I wanted to demonstrate.